Perhaps one of the most distinguishable physicists, Michio Kaku, has examined his assessment concerning this issue. Kaku, known for his significant contributions to the fields of theoretical physics, has recently noted that the James Webb Space Telescope has detected 6 massive galaxies that scientists once thought were incapable of existing. These discoveries could potentially open up new perspectives on how we understand the universe. It is, therefore, both fascinating and worth closely examining these developments. Kaku is a prominent figure in the scientific community, a physicist of American and Japanese heritage. He is regarded as an expert in both theoretical physics and quantum mechanics. Unlike some more conservative and skeptical scientists, Kaku has been open to the astonishing recent discoveries of the James Webb Space Telescope, JWST mission. We are fortunate that this esteemed expert has chosen to speak out about what can no longer be denied. The excitement and deeply thoughtful tone of the renowned physicist are evident in his remarks on the findings made by the James Webb Space Telescope. He suggests that these discoveries have reignited his interest. We should examine the implications of Michio Kaku's revelation of these 6 massive galaxies. Kaku is a scientist who has consistently been able to propose new hypotheses throughout his career. He appreciates that Einstein's theory of relativity and Newton's laws are insufficient to explain the universe's full complexity. Kaku understands that the revelations of the new telescope could fundamentally reshape the scientific field, although many of his colleagues have been unable to embrace this view. This has caused concern and debate among both supporters and critics of quantum mechanics. However, this intellectual challenge evokes amusement from Kaku. The JWST has uncovered 6 gigantic galaxies dating back to the universe's earliest stages. Each of these massive galaxies contains more stars than our own, despite forming only a brief time after the Big Bang. The team of cosmologists responsible for the discovery has named these remarkable structures universe breakers, as their existence could alter our entire understanding of the universe. Something here no longer aligns with the Big Bang theory. The theory posits that the universe was a chaotic place after its inception. The first solid objects required a few 100 million years to form, and it took additional time for these objects to reach sufficient density to produce light. The development of complex structures like galaxies should have occurred much later. Some of the newly discovered galaxies surpass the size of the Milky Way. Their enormous size suggests that they were possibly forming new stars at an astonishing rate, perhaps several per year, while our own galaxy forms stars at a much slower pace. The exact timing of the first galaxy's formation remains uncertain. Until recently, scientists have been unable to determine this. One clear fact is that initially, there could have been only single stars or groups of stars that eventually merged into increasingly larger structures, ultimately forming dwarf galaxies that underwent mergers and continued to grow, according to previous theories. These theories suggested that advanced and massive galaxies could not have existed so early, raising questions about whether the universe is older than previously thought or whether complex large-scale structures emerged much earlier than expected. This current situation challenges conventional physics, which still grapples with this model. Some areas of physics have strongly dismissed this discovery, highlighting potential errors in age estimates. Aware of this, Kaku stated, there are numerous instances of outdated and erroneous theories that persist due to the rigidity of certain experts. Many of these theories were eventually disproven when empirical analysis revealed their flaws. Therefore, the critical work in any science, particularly in physics, rests with the experimentalists who uphold the validity of research through verifiable evidence. On Earth, we have minimal data on the universe's true origins. The Big Bang theory was established in 1927 based on observations of the universe's expansion. This information led to the conclusion that the universe began from a single point and has been expanding ever since. At the time, it was difficult for people and scientists to imagine a universe with a beginning and an end. The concept of a universe that had always existed and was infinite in time was beyond human imagination. Even today, scientists still face challenges in understanding it. However, it is essential to reconsider these possibilities. These new findings do not align with what scientists have relied on for decades regarding the universe's formation theory. Science has repeatedly shown that reevaluation and openness to bold ideas are essential components of the scientific process, as much as the confirmation of established theories and observations. When Einstein was a young scientist, he believed that planets were fixed in the universe and that specific structures occupied defined spaces. However, we now understand that everything in the universe is moving. Planets orbit stars. Stars move within their galaxies at different rates, and entire galaxies rapidly move through space, their ultimate fate still unknown. Scientists are challenged to accept inconvenient discoveries. It is understood that theories are not merely speculations or grand insights until they are fully tested or confirmed by undeniable observations. The concept of the Big Bang emerged from evidence that galaxies are moving away from each other, with the distance being proportional to their separation from Earth. This observation, known as Hubble's law, suggested that the universe has been expanding for a long time. Additional evidence, such as cosmic microwave background radiation and the redshift of light from distant galaxies, further supports this theory. However, it is crucial to remember that those who once believed the Earth was flat or that the Sun revolved around it also had similar kinds of evidence for their doubts, until advances provided a clearer picture. Today, we are witnessing a similar situation. Scientists expected the JWST to validate assumptions about the Big Bang. Instead, they found 6 galaxies that appear too large for their age. This reminds us that science is constantly evolving, and experts must remain open to new discoveries and reconsider existing theories based on available evidence. Scientists use redshift as a tool to determine specific measurements in the study of the universe. Redshift, also known as the Doppler effect, refers to the change in the color of light as the light source and observer move relative to each other. To understand this, imagine hearing a car engine get louder as it approaches you, but the sound decreases as it moves away. The same happens with light. When a light source, such as a distant star, moves toward us, the light shifts toward the blue end of the spectrum. When it moves away, the light shifts toward the red end. This phenomenon is known as redshift. Physicists have translated redshift values into speeds and distances to calculate measurements in the study of the universe. However, it is important to note that small errors in these calculations could have significant implications. The methods used in the past are now under review, and the outcomes that scientists will arrive at regarding the latest discoveries related to our universe are exciting. It is essential to consider whether these results are genuinely based on redshift errors, or if some scientists are simply denying the facts. This is a question that requires serious assessment and a careful review of the data and methods used in the study. As scientific inquiry progresses, discoveries made by instruments like the James Webb Space Telescope frequently challenge our assumptions about the universe. The ongoing discovery of 6 massive galaxies dating back to the beginning of the universe is one such example. These galaxies, which defy the standard theory of galaxy formation, raise fundamental questions about the timelines and processes involved in the development of large-scale structures. The James Webb Space Telescope, a successor to the Hubble Space Telescope, is equipped with advanced technologies that allow it to peer deeper into space with remarkable clarity. Its ability to detect light from the farthest reaches of the universe gives astronomers a window into the past, allowing them to study galaxies that formed billions of years ago. The discovery of these ancient and massive galaxies challenges existing models that predicted such large structures should have formed much later in the universe's history. The implications of these discoveries extend beyond cosmology and into the realm of theoretical physics, compelling scientists to reconsider established theories about the early universe. These discoveries also highlight the importance of remaining open to revolutionary ideas and updating our understanding based on empirical evidence. Kaku has emphasized the pivotal role of scientific validation in shaping our view of the universe. Pointing out that theories must continually evolve to accommodate new data, Kaku stresses that scientific progress hinges on our ability to embrace new ideas and revise our theories in response to new discoveries. He believes that as the field of physics evolves, it is essential to remain flexible and open to the unexpected. The groundbreaking discoveries made by the James Webb Space Telescope demonstrate that the universe is far more complex and surprising than we once imagined. The implications of these findings are profound. If these early galaxies, which appear to be much larger than expected for their age, were indeed forming stars at a rapid rate, this could change our understanding of cosmic evolution. It raises the question, what did the universe look like in its infancy? Were the first galaxies much more massive and sophisticated than previously thought? The implications stretch beyond just cosmology into the realm of astrophysics, as these discoveries challenge long-held assumptions about how galaxies and stars form. Furthermore, these findings could have far-reaching effects on the study of dark matter and dark energy, two of the most elusive and mysterious components of the universe. The fact that these massive galaxies exist so early in the universe's history might suggest that the distribution of matter in the early universe was more complicated than the current models allow for. This could potentially shed new light on the nature of dark matter, which is believed to make up a large portion of the universe's mass, but has yet to be directly observed. As the data from the JWST continues to accumulate, scientists will need to reconcile these discoveries with existing theories about the formation and evolution of galaxies. Some may argue that these findings could be explained by errors in the measurement of redshift or other observational methods. But as Kaku points out, history shows that many scientific theories that were once widely accepted were ultimately proven to be flawed. This only reinforces the importance of ongoing experimentation, peer review, and the willingness to update our understanding of the universe as new information becomes available. The challenge, according to Kaku, lies in how we balance our existing knowledge with the new revelations that the James Webb Space Telescope has provided. It is not just about proving new theories, but also about refining old ones, making them more inclusive and capable of explaining the broader complexity of the universe. In conclusion, the discovery of these massive galaxies by the James Webb Space Telescope forces us to confront some of the most fundamental questions about the origins and nature of the universe. It challenges current models, questions long-held assumptions, and opens up exciting new avenues for research. As Kaku emphasizes, the true spirit of science is in the constant pursuit of knowledge, and we must remain open to the unexpected. This is how progress is made, and it is through this process that our understanding of the universe will continue to grow and evolve.